All right. So if you take a peek at numbers 20 through 22, they're just like 17 through 18, but you do need to find the slope first. And so 23 through 25, you're just determining if they're parallel or perpendicular by looking at the relations of the slope. Now, since 26 through 29 involve that same concept but are a little more complicated because you have to write the equation, I'm going to do one of those. I think maybe the hardest one to do would be 28. So I'm going to do 28 in this video. Let's see here. 28, it has to go through the point 85, and it's got to be perpendicular to 2x minus y equals 7. All right, so the first thing we're going to do, we need to find the slope of this line so we can find the opposite reciprocal. So if I subtract 2x and subtract 2x, and I get negative y equals negative 2x plus 7. Now I need to get that y to not be a negative y, but a positive y. So y would equal 2x minus 7. So the slope of this line equals 2. And since we want a perpendicular line, we want the opposite reciprocal of 2. So the slope that we're going to use is m is equal to negative 1/2. Okay? So now we have x1 and y1. And we're going to plug this point and this slope into point slope form. So we would get y minus 5 equals negative 1/2 x, negative 1/2 times x minus 8. Okay, so now I'm going to distribute, and y minus 5 will equal negative 1/2 x plus 4. And then I'll add 5 to both sides. And then y equals negative 1/2 x plus 9. That is slope-intercept form. I might say to give it in standard form on the test too, so just in case it does, I'm going to put this in standard form. Why is it not in standard form? I need the x term to go to the left side. If I do that, if I add 1/2 x, I would get 1/2 x plus y equals 9. Then, to get rid of the fractions, I multiply by 2, everything by 2, and I get, let's see, 2 times 1/2 is x plus 2y equals 18. That would be the standard form. We've practiced that a lot. Hopefully you get it. All right. I'm going to do just a couple more problems here. I'm going to do one where we determine whether a relation is a function. And let's find the domain and the range. Are you ready? Let's do, I think, number 31. Number 31, and then if you look at 30, 33, 34, 35, 36, 37, 38, 39, all those are basically the same type, but let's do 31 together. So for 31, I have the points 5, 9, 4, 3, I have 6, negative 7, and I have negative 5, 9. All right, so let's see. Is it a function? What do you think? Well, oh my goodness, I need to adjust this so you can see. There we go. All right, so I have 5 producing 9, 4 producing 3, 6 producing negative 7, and negative 5 producing 9. So everything's okay. Each input produces only one output. So yes, it's a function. What's the domain? All possible x values. So that would be, let's see, if I put them in order, you don't have to, but I'm going to do it from smallest to biggest. The smallest x value is negative 5, and then I have 4, 5, and 6, okay? And then the range, all possible y values, would be 3, oh, let's go from smallest to biggest. So negative 7, 3, and then 9 repeats itself, but that's fine. So the last value for the range would be none. We only have to list it once. Okay, so I know that problem only asks you if it was a function, but since the other problems ask you for domain and range, I kind of included in that. Now, this is about all the time I had to make videos for. I tried to cover a little bit of everything, but I'm gonna put an answer key for this review, okay? And anything that you do not understand, you need to ask me in class. I wish I had time to do a video for every problem, but it just don't. Not enough hours in the day. Okay, thank you all for watching the videos. I'm gonna look forward to this test. Hopefully it's as good as the last one. I'm so proud of you guys, worked so hard, especially if you're watching this video. Thank you so much. Have a great night.